Alrighty, here we got merged two binary trees. Now, this is pretty simple. The idea is really simple. Take this tree and place it on top of tree 1. If we do that, if the node values are not going to be null, then just add them up. So let's consider 1 right there, 2 right there, bam, we add them up. That's it. Now, what if we have 5 and this is null? It's not going to matter. Like, think of it just putting tree 2 on top of tree 1. It's not going to matter because it's null. There's nothing there. So it's still going to output 5. Now, it's a binary tree. For most binary tree questions, think of recursion. And now, how do we traverse that? Top to bottom is the best way, so pre-order is going to be the best thing that we can do right now. The structure for pre-order is pretty basic. We have the base case, left traversal over here, and then right traversal. It's called pre-order because the pre comes from this condition that is before the left and right traversal. So here is some condition that we're going to apply for the algorithm. Now, let's do the base case first. So, in base case, if T1 and T2 are equals null, then return null. That's it. Now, the condition is pretty tricky. This is the majority of the code and where it goes. Now, let's see for this question. So we have 4 cases. The first case is if both of the nodes are null. We got that one covered, so we have 3 cases now. The second case is if both of the nodes are not null. For example, 3 and 1. They're not, so we got to add them up. That's case 3. Case 2 can be if tree 1 has a node that is not null, and tree 2 has a node that is null. And case 1 is vice versa. So we need some code here that represents all 3 of the cases. We can do this in a lot of different ways, but the cleanest way, I feel like, would be to use a ternary operator. And it's going to look complicated, but it's not bad at all. We have a condition. T1 equals null. For now, that's all we have. So T1 equals null. If this is true, then we want to plug in 0. So basically, if this is true, 0 in value is going to equal 0. If it's not true, it's going to equal T1.val. So one more time. If T1 is null, it's going to plug in 0 to in value. If T1 is not null, it's going to plug in T1.val into the in value. We're going to add that with one more. If T2 is null, then we're going to plug in 0. If it is not, then we're going to plug in T2.val. So this makes a lot of sense because this one line of code covers the 3 cases. If T1 is null and T2 is not, this is going to plug in 0. This is going to plug in T2.val. And that's going to be our in value. Now the other way around. Let's see that this one is not null. It's going to plug in T1.val plus 0. And yeah, that was the majority of the work right here. Now, left and right traversal is just going to include basic traversals, merge trees. Now, the thing is that we need a way to make a new node and place this value inside that node. So we can just do tree node value equals tree node value. And actually not value, but we can just name this node. So now we need a traverse. And we have to assign, since it is a left traversal, we have to connect whatever gets returned here to this node. The way we do that is that we do node.left equals merge trees. This might seem a bit confusing, but it's actually not that bad. It's the same concept as this. We're going to still use ternary operators. So if the condition is T1 equals null, if it is true, we're going to return null. If it is not, we're going to return t1.left. And we're going to do the exact same thing on the other side for t1, my bad, t2. So t2, and we're going to do t2. So one more time. So we're going to call merge trees again because it's a recursion. If t1 is going to be null, it's just going to return the null for this parameter. If it isn't, it's going to put through t1.left. The same thing for this side as well. Now, the right traversal is going to be the exact same thing. We just copy and paste this right here. So let's go through it. We got node.right equals merge tree. If t1 equals null, if it is true, return null. If not, you want to plug in t1.right. Same thing over here, t2.right. I'm going to take these off because that's going to cause an error. And then all you want to do is just return the node. And this should pass all of the cases. And yeah, so that was it.